We are starting on factoring and operations with complex numbers. So to factor a polynomial, the first step is that we want to write the polynomial in standard form. Then we're always going to want to factor out any greatest common factor, or GCF. Then we're going to check the number of terms. So if we have a binomial, remember binomial is two terms. Our first step is to check to see if it's the difference of two squares. So that's going to be set up as a squared minus b squared. And we factor into a plus b times a minus b. If it's not the difference of two squares, then we're going to check to see if it's the sum or difference of two cubes. So that would be a to the third plus b to the third, or a to the third minus b to the third. And if we remember, our acronym for remembering the signs of this is SOAP. So same, opposite, always positive. So if you have a to the third plus b to the third, we factor it as a plus b, so same sign, times a squared minus opposite sign, ab plus b squared, always positive. If you were to start with a to the third minus b to the third, we would have a minus b, that's that same sign, times a squared plus opposite sign, ab plus b squared. That's our always positive. So those are your two options for a binomial once you factor out your greatest common factor. If it's a trinomial, so remember that's three terms, we're going to check to see if it's a perfect square trinomial. So that is your a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. And either way, that would factor into either a plus b squared or a minus b squared. So if it's not a perfect square trinomial, then we're just going to factor by guessing and checking. Remember that last term tells us our sign. So if the last term is positive, we want to find a sum, or that our factors are going to have the same signs. Then if our last term is negative, we're going to find a difference, or we're going to have different signs. If we have a polynomial with 4 or more terms, we're going to want to factor by grouping. So in order to do that, we're going to group terms in pairs. Then we're going to factor out the greatest common factor from each pair. Then we're going to factor out the greatest common factor, and this should be a binomial from each remaining term. So once you've done all of that factoring, either it's a binomial, trinomial, or factoring by grouping, then we want to check to make sure all factors that have a power of 2 or greater are completely factored. If you can factor again, then factor again. We have 2x squared plus x minus 15 for our first example, and we want to factor this completely. So looking at this, I know that the only thing that multiplies to 2 is 2 times 1. And I know my factors of 15 are 1 times 15, 3 times 5. So if I start factoring this, I know I'm going to have a 2x and an x. And I need to subtract to get to positive 1. So I know that 2 times 3 is 6, minus 5 will give me 1. So I have 2x minus 5 times x plus 3. B, I have negative 2x squared plus 4x plus 6. So anytime that I start, my leading coefficient is a negative. My first step is to factor out a negative. So I'll have negative 2x squared. So my next problem, I have negative 2x squared plus 4x plus 6. Anytime my leading coefficient is negative, I want to factor out a negative. And I can see that my greatest common factor is actually negative 2. So I'm going to have negative 2 times x squared minus 2x minus 3. So I'm going to factor x squared minus 2x minus 3 into x minus 3 times x plus 1. Make sure when we're factoring, we bring that greatest common factor into our answer. Okay, C, we have x squared minus 2x squared minus 3x plus 6. So I know I'm going to have to factor by grouping. So I'm going to go ahead and take out an x squared from my first group. So I'm left with x minus 2. I have negative 3x plus 6. So I need to take out a negative 3. I'm left with x minus 2. So I take my GCFs. So I get x squared minus 3 times x minus 2. Then I just need to check, can I factor x squared minus 3 more? The answer is no, I cannot. So our answer is just x squared minus 3 times x minus 2. D, we have 9x squared minus 49. First thing I always want to do is check to see if that is a difference of squares. And it is. My A would be equal to 3x. My B would be equal to 7, so that's just taking our square roots. So when I factor this, this would just be 3x plus 7 times 3x minus 7. Our next example, we have 2x to the third plus x squared minus 32x minus 16. So again, since we have 4 terms, we're going to need to factor by grouping. I factor out an x squared, and I'm left with 2x plus 1. Then I factor out a negative 16, so I'm left with 2x plus 1. So I'm going to go ahead and factor out this 2x plus 1. That's my GCF of those. So I have 2x plus 1 times x squared minus 16. And then I need to check, can I factor x squared minus 16 more? And the answer is yes. It's the difference of squares. So a is equal to x, b is equal to 4. So we're going to go ahead and factor into 2x plus 1 times x plus 4 times x minus 4. And that's going to go ahead and be our final answer. F says negative 8x to the third minus 27. So we're going to go ahead and factor out a negative 1 to start. So I'm left with negative 8x to the third plus 27. So I want to check, is it the difference of squares? The answer is no. Is it the sum or difference of cubes? Yes, it is. It's the sum of cubes, where a is equal to 2x, b is equal to 3. So remember to bring your greatest common factor, that negative 1, into our final answer. We factor this into 2x plus 3 times 4x squared minus 6x plus 9. And you'll never be able to factor this trinomial here. Those will never be factorable once you're doing the sum or difference of cubes. So I know that I got my final answer. So now we're going to start with our operations with complex numbers. So remember, a complex number is a number that is in the form of a plus bi. And the conjugate of a complex number a plus bi is just a minus bi. Remember that the square root of -1 is just I, and that powers of I follow a pattern that occurs in 4s. So I to the first is just I to the second is -1, I to the third is -I, and I to the fourth is just 1. So when we're asked to find the value of I to a power, we're just going to divide the power by 4, and the remainder is equivalent of I that the reminder's power, to that reminder's power. So basically, if 4 goes into the number 10 times with 3 left over, you'd be left with I to the third, so your answer would just be -I. And we'll go through some examples. So when we're looking at operations, if we are adding complex numbers, we want to add all the real parts together, so those are your A's, and add the imaginary parts together, those are your BI's. When we're subtracting complex numbers, you want to make sure you distribute the subtraction to both the real and the imaginary parts, and then you'll just follow your addition rules. When we're multiplying the complex numbers, we're going to distribute the real part of the first complex number to both parts of the second complex number, and then we'll distribute the imaginary part of the first complex number to both parts of the second complex number. Then we'll add. So basically you're foiling. If we think back to when we multiplied binomials, you're going to FOIL out the complex number. We don't want to forget that I squared is equivalent to -1, so you will have to change that. When we're dividing complex numbers, we want to make sure we multiply the complex number when it's in the form of a fraction by a form of 1. It will be in the form of the complex conjugate of the denominator over itself. So basically we want to take the complex conjugate of the denominator and multiply our numerator and denominator by both of those. Okay, so we have I to the 133. So we're going to take 133. How many times does it go into 4? It goes into 4 33 times with 1 left over. So what that basically means is that this gives us I to the first. So I to the first is just going to give us I. B, we take 602, we divide it by 4, gives me 150 with 2 remaining. So that's going to be equal to I squared. And we know that I squared is just equal to -1. I to the 64th. So 64 divided by 4 goes in evenly 16 times. So when it goes in evenly, it's basically I has 0 remainder. So that's just going to be an answer of 1. So we take the square root of -50, and I know that -50, so we take out that negative is going to come outside as an I. We know 50 is just 25 times 2. So this is going to simplify to 5I radical 2. So remember, the square root of -1 is just I. So anytime you have I under the square root of 1, anytime you have a negative underneath the square root, you're just going to take that out as an I. E says -2, square root of -132. So I know that 132 is just 4 times 33. So that negative 2 stays outside. Square root of 4 is 2. And then that negative is going to come out as an I. So we have times 2i. Square root of 33. We simplify this, we get negative 4i square root of 33. Next example, we have the square root of negative 240. So I know that 240 breaks down to 16 times 15. Square root of 16 is just 4. That negative 1 comes outside as an I. So we'll be left with 4i square root of 15. Now let's look at operations with complex numbers. So on this one, we're saying 3 plus 4i plus negative 7 plus 5i. So we're just going to take the real parts and add the real parts. So we have 3 plus negative 7. That gives us negative 4. Now we're going to go ahead and add our imaginary parts. So 4i plus 5i just gives me 9i. So our final answer is negative 4 plus 9i. Now let's look at h. H is a subtraction, so we have 9 minus 2i. And we're subtracting from that 4 minus 3i. First thing I'm going to do is go in and change this to addition and distribute our subtraction. So we're actually saying 9 plus negative 4. That gives us 5. We have negative 2i plus 3i, so that gives us positive I. So our answer is just 5 plus I. Last operation left is multiplication. Or sorry, not last one. Next operation is multiplication. So all we're going to do is distribute. So we're going to take this 4, multiply it by both parts. So 4 times 3 is 12. 4 times I is 4i. Now we're going to take negative 2i times 3. So that gives us negative 6i. Negative 2i times I gives us negative 2i squared. We need to remember that I squared is just equal to negative 1. So when I simplify this a little bit, I get 12 minus 2i when I combine these like terms, minus 2 times negative 1. 12 minus 2i stays. Negative 2 times negative 1 gives me positive 2. Now all I'll do is combine my like terms, so I get 14 minus 2i. So remember, like terms means we're adding the real parts, adding the imaginary parts together. Okay, J, we have 5 minus 2i squared. So remember, this is a binomial theorem, right? So if you need to, rewrite this as times 5 minus 2i, or remember our formula for a minus b squared. That's just going to be a squared minus 2ab plus b squared. So either way, use whichever one method works better for you. So here I'm going to get 25 minus 20i plus 4i squared. We can keep this as 25 minus 20i plus 4 times negative 1. So we're left with 25 minus 20i minus 4. Combine 25 minus 4, so that gives us 21 minus 20i. Now we can take a look at a division. So we have 6 minus 7i over 1 minus 2i. So this is where we need to multiply by the complex conjugate. So I'm going to multiply numerator and denominator. So we're multiplying both of them by 1 plus 2i over 1 plus 2i. So we're switching that sign of our denominator. So I'm going to go ahead and FOIL that out. So I get 6 plus 12i minus 7i minus 14i squared all over. So we need to remember that those like terms are going to cancel. So 1 times 1 is 1. Again, we get plus 2i minus 2i minus 4i squared. These terms cancel. These will combine. So we're left with 6 plus 5i minus 14 times negative 1 over 1 minus 4 times negative 1. So this simplifies to 6 plus 5i plus 14 over 1 plus 4. I combine my like terms of 6 and 14, so we get 20 plus 5i all over 5. And I see that 20 and 5 are both divisible by 5, so I can simplify this to just 4 plus I. So make sure the coefficients of your real part and your imaginary part are both divisible by that denominator before you simplify. Okay, last problem. We have 8 plus 16i over 2i. First thing I see is that everything is divisible by 2. So I'm going to make my life easier. So I get 4 plus 8i all over I. Now I'm going to go ahead and multiply by the conjugate. And I can go ahead and multiply numerator and denominator both by I over I. So I end up with 4i plus 8i squared all over I squared. So this gives me 4i plus 8 times negative 1 all over negative 1. So this gives me 4i minus 8 all divided by negative 1. So I'm just going to go ahead and simplify that and divide everything by negative 1. And then I always like to have my real part first. So negative 8 divided by negative 1 is 8. 4i divided by negative 1 is negative 4i. So I have 8 minus 4i as my final answer.